Hello, I'm Takehiro Nakamura of NTT DoCoMo. Thank you for giving me a great opportunity to explain 60 activities in Japan. It is a great honor for me to provide my presentation for 60 flagship webinar. In my presentation, I would like to provide two kinds of presentation. At first, I will explain white paper of Beyond 5G Promotion Consortium in Japan as the chair of White Paper Subcommittee of the consortium. Next, I will explain NTT DoCoMo's concept and activities for 5G evolution and 6G on behalf of NTT DoCoMo. Beyond 5G Promotion Consortium is the 6G project in Japan. We developed the white paper of the consortium titled Message to the 2030s. After this, I will explain overviews of the consortium and the white paper. Beyond 5G Promotion Consortium was established in December 2020 to promote Beyond 5G promotion strategy through industry, academia, government collaboration. The forum is configured by two committees, Committee for Planning and Strategy and International Committee. Under the Committee for Planning and Strategy, White Paper Subcommittee was established to develop the white paper of the consortium. In the White Paper Subcommittee, we have three working groups and an ad hoc group: Vision Working Group, Technology Working Group, Spectrum Working Group, and the WP5D ad hoc. Thanks to aggressive discussion and activities of members of the groups, we developed and published the white paper. Based on the white paper, WP5D ad hoc drafted contributions of Japan for IMT 2030 studies in ITO WP5D. We published white paper on the consortium website and updated to contribute to ITO WP5D timely manner. Version 1.0 was developed in March 2022, and the contents of this version was provided to WP5D workshop in June 2022. Version 2.0 was published in March 2023, and this is the latest version of the white paper. After this, I will explain overviews of the white paper version 2.0. This is structure of the white paper. We studied and captured variety of trends such as traffic, market in our industry, and other industry in chapter 2, 3, and 4, respectively. Based on these study results, we summarized capabilities and KPIs required in Beyond 5G in chapter 5. And we studied and summarized the technology trend for Beyond 5G in chapter 6. I think that one of the most interesting topics should be trends from other industries, captured in chapter 4. After this, I would like to explain overviews on it. This slide shows detailed contents of chapter 4, Trend from Other Industries. As you can see, we captured views from a variety of industries and clarified requirements for Beyond 5G from each industry perspective. I cannot explain all of them due to limited time, and I'd like to explain views of automotive industry in the next slides. This slide shows future views of automotive industry. Currently, we have serious issues in these industries, such as lack of drivers in rural areas, terrible traffic jam in urban area, societal crisis on energy and environmental issues, problems of traffic accident caused by aging society. Considering these issues, they identified 4 future visions. A society all people can move freely and efficiently, mass platform allowing the multimodal mobility of people, collaboration between vehicles with smart cities, enabling digital society to realize mobility inclusive. Based on the future vision of automotive industry, we studied requirement for beyond 5G. As a result of the studies, we identified requirements for safety driving assistance and automated driving separately. In 2030, we see that automated driving is realized. However, percentage of automated driving car is not so high, so beyond 5G should support both of safety driving assistance and automated driving. You see two figures. In both figures, horizontal line shows the evolution of capability. Left portion corresponds to current 4G 5G. Right portion corresponds to beyond 5G. Vertical line shows the evolution of applications of automotive industry. So right top corner portion, highlighted by a red square, corresponds to beyond 5G requirement for both industries. For safety driving assistance, we think that the complement V2I cooperation by sensing and enhanced connectivity and availability are required to support safety driving under extreme conditions, such as driving at the intersections without the signal, and bad weather or in the event of disaster. For automated driving, integrated sensing and communication, distributed AI learning, and inference, and high performance and security for remote monitoring and remote driving are required. Based on study results on industry views for beyond 5G, we summarized capabilities and KPIs required in beyond 5G in Chapter 5. This is capabilities required for beyond 5G. Requirements are different depending on use cases in industries. However, we see some similarities. Regarding data rate and capacity, 10 to 100 gigabps is required for many of use cases. For latency, 1 to several milliseconds are required. For local communication case, very short latency, 100 microseconds is required. For reliability, 10 to minus 6 and minus 7 are required for remote monitoring, control, and remote surgery, respectively. Centimeter level accuracy will be needed for positioning and sensing. Several millions to tens of millions of devices square kilometer will be required considering the spread of healthcare devices. Drastic coverage expansion will be required, such as 100% land coverage, sky, space, and moon. Based on study results I explained so far, we developed conceptual figure of IMT for 2030 6C. We took similar approach to that of IMT 2020. For IMT 2020, we identified 3 usage scenarios. For IMT 2030, we identified 6 usage scenarios: ultra broadband communication, ubiquitous sensing, mission critical communication, universal coverage, ultramassive connection, and intelligent connection. In ITU WP5D, many proposals of the conceptual figure were proposed, including 6C flagship and the Beyond 5G Promotion Consortium. We know that those figures have many similarities. As you may know, ITU WP5D agreed to define the conceptual figure in this June by hexagon figure with 6 usage scenarios. I noted the 2 6 usage scenarios of Beyond 5G Promotion Consortium and WP5D are almost same, though wordings are different. In principle, we should clarify user experienced KPI. It means end-to-end performance indicator for the other industries as much as possible. However, it is not so suitable for some of KPIs to define end-to-end performance target. so applicable range path is different depending on KPIs. This slide shows applicable path of the target KPIs. We hope that this can be good reference to define conditions for each KPI. This figure shows target KPIs for beyond 5G 6G. Considering the study results of the future views of vertical industries, we defined 8 KPIs: peak and user experience data rate, latency, reliability, energy efficiency, sensing accuracy resolution, area coverage, and connection density. As you can see, we set 10 times to 100 times improvement from 5G for each KPI. As technology trend, we conducted intensive investigation on potential technologies for 6G, including high-level observations, system platform and application, trustworthiness, network energy efficiency enhancement, network coverage extension via non-terrestrial networks, network architecture, wireless and optical. Due to time limitation of my presentation, I'd like to skip detailed explanation on the technology trend in our white paper. If you have any interest in our study results on technology trend, please visit Beyond 5G Promotion Consortium website. I'd like to conclude the first part of my presentation on Beyond 5G Promotion Consortium white paper. This white paper contains useful information which promote to study on new future business and solutions for social issues among all industries, not limited to communication industry. We will continue our study and to contribute to spectrum study and the standardization activities in ITU and 3GPP, and conducting collaborations among industry, academia, government based on the white paper. We are very pleased to continue our close collaboration through exchanging views on Beyond 5G 6G with 6G flagship. If you have any comments or questions about our white paper, please feel free to contact me. From here, I'd like to provide the second part of my presentation on NTT DoCoMo's views and activities for 5G evolution and 6G on behalf of NTT DoCoMo. Cyber Physical System (CPS) or Cyber Physical Fusion (CPF) is essential and fundamental to provide and create new services for now. They will be more important and will be advanced in the future. Huge amount of data need to be transferred from physical space to cyberspace. The data is analyzed and processed by AI in the cyberspace, and then the processed data should be actuated in the physical space real-time manner. Network of 5G evolution and 6G will take very essential role between the physical space and the cyberspace to support future CPS, CPF by its 6 extremely high performance characteristics in terms of data rate, capacity, low latency, coverage, reliability, energy and cost, and massive connectivity and sensing. DoCoMo is aggressively studying technologies for 5G evolution and 6G. This slide shows 4 kinds of our technical activities. Technologies for millimeter wave coverage improvement, including Metasurface and RIS. Technologies for sub-terahertz, coverage expansion by NTN HAPS, and the technologies for industry use cases, including communications and sensing. I will explain some of them after these slides. At first, I will explain our views and activities for millimeter wave coverage improvement. Technologies for millimeter wave defined in 5G specifications of 3GPP and the spectrum bands such as 28 GHz, were allocated in many countries, including Japan. On the other hand, millimeter wave is not so deployed and used well globally. However, millimeter wave has excellent characteristics thanks to very wide spectrum bandwidth, and we can achieve very high data rate capacity and low latency. We expect we need to use millimeter wave more in the future as evolution of 5G and 6G. This slide shows 4 reasons why we need to use millimeter wave more. Mobile data traffic will increase continuously, and we need to deploy more spectrum resources. Left top figure is from GSMA report, and this report expects 5 GHz millimeter wave spectrum resources will be needed for EMBB, FWA, and enterprise solutions by 2030. Excellent high-quality 5G use cases such as 4K, 8K video, XR devices, robot, industrial automation will be provided in the future. They will need very high data rate and consume high capacity. Currently, joint communication and sensing is one of very interesting technical topics, and higher frequency such as millimeter wave can improve accuracy of the sensing. And also, more use of existing millimeter wave with advanced solutions can be an initial accomplishment that open the way for millimeter wave and sub-terahertz deployment in 6G era. We are investigating many technologies as the new solutions for the new radio network topology. As antenna technologies, we are testing on-glass antenna and pinching antenna using dielectric waveguide. These solutions are inconspicuous and easy and ready to use. As radio XHO, radio fiber is a better solution for wider bandwidth signal of millimeter wave. OAM MIMO multiplexing can achieve super high-speed data transmission for XHO. We have many repeater technologies: millimeter wave repeater system, passive reflector, RIS, and the Metasurface technologies are very interesting solutions which can extend millimeter wave coverage easily. We are studying these solutions and conducting field trial aggressively, aiming commercial deployment for millimeter wave promotion. From the next slide, I will explain some trial results of Metasurface lens and RIS. This picture shows Metasurface lens we used for our trial. With this Metasurface lens, we can focus energy of radio signal from the base station into a focal point. Our simple experiment results shows that the gain is more than 24 dB. This is a deployment image of the Metasurface lens. If we can cover the window by the Metasurface lens, set the focal point of the Metasurface lens on the ceiling, set the repeater at the focal point, and amplify and retransmit the signal by the repeater, we can improve indoor coverage by radio signal from outside base station very easily. We conducted the trial of the Metasurface lens in real environment. Base station was set outside of the conference room and transmit 28 GHz radio signal to conference room. At the entrance of the conference room, we set the Metasurface lens. A repeater was set at the focal point of the lens. This slide shows the trial results. Heat map at left-hand side shows the measurement results of received signal strength, RSRP. Left-up heat map shows the case of no lens and no repeater. As you can see, area coverage is so limited. Middle of the heat map shows the case of no lens and with repeater. area coverage was improved thanks to repeater, but not so enough. Bottom of heat map showed the case of with lens and with repeater. Area coverage was so improved, and the whole of the conference room can be covered very well. Right-hand side graph shows the CDF of measurement RP. We can see about 10 dB gain thanks to combination of the repeater and the metasurface lens. This is another our activities on RIS. We developed RIS system which has capability of user tracking. The metasurface reflector dynamically changes reflection direction by using environmental information on location of moving receiver. This slide shows the result of our trial of RIS. We conducted the trial indoor. We set the base station 20 meters away from the room where the moving receiver located. Figure shows the heat map of the received signal strength measured by moving receiver. Upper figure shows the result of no RIS reflector. As you can see, loss area was covered with good radio condition. However, N-loss area was very bad or no coverage. Bottom of figure shows the result of with the controlled RIS. As you can see, N-loss area coverage improved by up to 20 dB gain thanks to RIS capability, reflection, direction control. These results shows potential use case of RIS to improve indoor coverage. This slide shows our simulation results on millimeter wave coverage enhancement by RIS network controlled repeater, RIS NCL. Simulation conditions are millimeter wave dense urban scenarios with 3 blind spot areas per sector and the 3 RIS NCLs deployed correspondingly. The simulation results showed that the RIS NCL with 0.5 meter by 0.5 meter can eliminate the blind spot effect, and the RIS NCL with 1 meter by 1 meter can achieve 8 dB SINO improvement in average. This simulation result shows potential effectiveness of RIS NCL for millimeter wave coverage enhancement. This slide shows 2 public or private collaboration activities for millimeter wave promotion in Japan. MIC established 5G Business Design Working Group to explore 5G business utilizing millimeter wave. In the working group discussion, members of the working group including DoCoMo and the major operators and the vendors expressed positive opinions for millimeter wave deployment. Mobile Communication Promotion Forum 5GMF millimeter wave promotion ad hoc was established in this January. Actually, I'm a chair of this ad hoc. The ad hoc published white paper in this March and organizing event to promote millimeter wave. This slide shows contents of the white paper of 5GMF millimeter wave promotion ad hoc. The white paper was published on 31st March this year. We conducted exhaustive investigation on millimeter wave, including challenges, technologies, solutions, and so on. And the results of our investigation was captured in the white paper. We developed and published the white paper in Japanese and English. You can download this from 5GMF website. I'm very happy if you have any interest in this white paper and give us your feedback or questions. We believe that coverage should be expanded drastically toward the 6G era, not only area where people live, but also 100% of geographical area, sea, and sky should be the communication coverage in 2030s. Conventional terrestrial network cannot be the solution for drastic coverage expansion. Non-terrestrial network, so-called NTN, is the solution for it. We can have three kinds of approaches for NTN: ZEO, LEO, and HAPS. ZEO satellite communication services have been provided all over the world, including Japan. Very wide coverage services can be provided by ZEO. On the other hand, performance in terms of data rate and latency is not so good due to very long distance. LEO is a very interesting solution now. Several major companies have launched so many satellites already, and initial LEO communication services have deployed already. HAPS, High Altitude Platform Station, is also a very interesting solution. We can expect very high performance with HAPS thanks to very short distance, 20 km. We think that multi-layer NTN system with ZEO, LEO, HAPS should be considered in terms of balance between cost, coverage, and performance. We believe that HAPS can support more business use cases thanks to very high performance in terms of data rate and latency. This slide shows the potential use cases of HAPS. Not only use cases for disasters, but many industrial use cases can be considered, such as IoT, construction site, event, ships, and flight. We have already started partner collaboration with NTT, Airbus, and SkyPerfect JSAT to accelerate development of NTN services. Airbus has already developed UAV, so-called Zephyr. We conducted the radio measurement trials using Zephyr and got very good results, shows excellent potentials of radio communications with HAPS. And NTT, our parent company, and SkyPerfect JSAT established a company, Space Compass, to promote development of NTN system and services. NTT DoCoMo is actively collaborating with Space Compass now. With HAPS, we intend to deploy direct access services for user devices, smartphone, in consumer market. And we plan to use existing 4G, 5G base stations and core network with newly deployed gateway stations and HAPS for smooth deployment of HAPS direct access services and supporting seamless mobility between HAPS and the ground network. From here, I will explain our views and activities for spectrum extension to sub-terahertz. Globally, discussion on additional frequency toward 6E has started. This topic is one of very important topics to be treated WRC 23 and 27. We believe that 6E will be operated in various frequency bands to support the variety of use cases. In addition to the frequency bands already identified for IMT, new frequency bands should be identified for 6E. This figure shows our views on candidates for the new frequency bands for 6E. 7.125 to 24 GHz is for higher data rate and capacity with certain level of coverage. 92 to 300 GHz is for super data rate and capacity at local area. We know that frequency identification process is very complicated and difficult to conclude. DoCoMo will make best effort for this process toward 6E through collaboration with stakeholders in this area. We should develop experimental systems and conduct trials to evaluate performance of 6C technologies at sub-terahertz. However, it is premature to do it, and it is difficult to evaluate 6C system performance with many user equipments and at wide area by trials at real field. Therefore, we developed 6C simulator. In the next slide, I will show a screen capture video of 6C simulator. This simulator supports use of sub-terahertz frequency at factory environment. In this video, we set center frequency of 100 GHz and the frequency bandwidth of 8 GHz. Uplink and downlink throughput performance can be evaluated simultaneously, and the uplink-downlink ratio can be changed flexibly. BS antenna are set on the roof of the factory to have line-of-sight environment as much as possible. Left bottom graph shows the ratio of UEs, classified by downlink-uplink throughput. With this condition, many of UE can experience 10 to 50 GHz showed by green, as you can see. This slide shows details of evaluation results of the 6C simulator. We found that 6C can compensate for high propagation loss in the 100 GHz band by increasing numbers of antenna elements. Thanks to extreme wideband transmission with 8 GHz bandwidth, high beamforming gain by massive MIMO BSs, and increasing BS antennas, the percentage of over 100 Gbps achieves approximately 80%. And adding moving BSs, RIS, can reduce the blocking effect, and almost 85% of MS is over 100 Gbps. As I explained, sub-terahertz has excellent potentials to achieve very high performance. We see, however, we have many challenges and technical issues to deploy sub-terahertz in terms of radio propagation, RF device, modulation-demodulation, and air interface. We need to address all of them through collaboration with technical experts for each area, including academia, to solve the issues. DoCoMo has started some 6C trial collaborations with 5 major global vendors and NTT, our parent company. As you can see, we are addressing many technical topics with vendors such as AI-native air interface, distributed MIMO, sub-terahertz access, and radio propagation measurement. We intend to publish the trial results in the future to accelerate the study and the standardization for 6C. Joint communication and sensing is one of the hot topics for 6Z. I will explain our views on this. Sensing is a key to get data in physical space for future CPS/CPF. Sensing by radio has very good characteristics compared with use of other methods like camera in terms of accuracy, anomalous condition, cost, and privacy, as you can see in this table. And use of high frequency, millimeter wave and sub-terahertz can provide better accuracy and benefit for anomalous condition. As I mentioned earlier, millimeter wave features large bandwidth, narrow beam width, and high carrier frequency contribute to accurate sensing in terms of high range resolution, high angle resolution, and high velocity resolution respectively. Bottom-up figure shows a theoretical estimation on accuracy between millimeter wave and sub-6. Compared to sub-6, accuracy on range resolution, angle resolution, and velocity resolution can be greatly improved by 2 to 5 times. So many use cases of radio sensing have been discussed in 3GPP. I showed 4 typical use cases in this slide. Detection of intruder to railway is a very useful use case for safe operation of railway companies with low cost. If we can detect wild animals on the railway, we can take proper actions such as emergency stop in advance. Congestion detection is one of the most useful use cases for our business. This can be used shops, theater, event venue, and so on. Behavior and health monitoring is very essential use case to save human life. Local rainfall estimation is now very important use case due to global climate change. In Japan, we have serious local heavy rain disaster, so-called guerrilla heavy rain, every summer. If we can detect the local guerrilla heavy rain very quickly, we can mitigate the damage. We can monetize 6D digital physical fusion by sensing and AI. This slide shows architecture for sensing and AI. We can deploy multiple sensing measures including joint communication and sensing, sensors implemented in the network facilities, camera installed in HAPS satellite, and so on. Data detected by sensors is transferred to operators' MEC, and the data is stored and analyzed by AI and then utilized for many kinds of use cases very quickly and safe. Applications on the MEC can be developed and provided by the operator and the partners to provide excellent services in agile manner. Applications in the public cloud in Internet should be used as cooperation with other systems and stakeholders. At the last topic, I will explain our views and activities for innovative application in 6G era. Thanks to very high performance of 6G network in terms of extremely high data rate and low latency, 6G network can perform as a human nerves so that 6G network can augment and extend human capabilities. If we can share body movement, 5 senses, and emotions through 6G network as shown in this figure, we can realize very interesting and exciting new services which were described as science fiction, such as telepathy, telekinesis. We can go beyond the constraint of space and time and realize ubiquitous body, superhuman, and so on. To show potential application of human augmentation, we developed the Human Augmentation Platform for demonstration. This platform treats sensing data of human activities such as myoelectricity and haptics. The sensing data is registered, reproduced, and stored in the platform and can be actuated to robot and another human. I will show some demos of this platform. I'd like to introduce our human augmentation demos at MWC 2023. I will show video of our demos in the next slide. Before going to the video, I'd like to explain our demos briefly on this slide. We showed 3 kinds of demos: T-whisking robot, motion sharing, and field tech. In the T-whisking robot demo, human arms motion is transferred to robot. Small myoelectricity sensors on human arms can detect human arm motion. The detected data is transferred to the human augmentation platform. At the platform, data is reproduced for configuration of a robot, and the reproduced data is transferred to robot so that robot can copy the motion of the human. This demo shows some potential of work style innovation or skill transfer in the future. Human motion can be transferred to another human also. This is motion sharing demo. We think this can be used for learning instruments. For example, we showed two demos, saxophone and the drums. In the saxophone demo, arm motion of person wearing white shirts were transferred to person wearing red shirts. In the drums demo, motion of arm and foot of person wearing white shirts were transferred to two person wearing red shirts. Motion of right arm and foot of white shirts person was transferred to red shirts person on the left. Motion of left arm and foot of white shirts person was transferred to red shirts person on the right. In the field tech demo, we showed transfer of haptics. One of our demos showed real-time transfer of haptics between the sensor and an actuator. Another one is new impressive experience of combination of video and haptics. Okay, let's go to the video. Sorry that you see Japanese text to explain this demo at bottom. I think many of you cannot understand Japanese text and please ignore it.
This shows how people's movements are shared in real time by playing the saxophone.
Okay, I hope you enjoyed our demo video and have some interest in human augmentation. It is initial phase of human augmentation activities now. We will try to treat more human body functions in the human augmentation platform: emotions, sensations, muscle, and easy brain. We will treat simple ones at first, and then treat more complicated ones, and combinations of functions so that we can create innovative services which can solve social issues and be useful for well-being society in 6G era. That's my presentation. Thank you for your attention. I hope to have opportunities to discuss 5G evolution and 6G with 6G flagship members and others in the future. Thank you.